Hi again, everybody. My name is Greg Anderson, and this is the Good Timekeeping Show with Greg Anderson. Today, a video that's inspired by a question my kids asked. You see, we have in our family room where we watch TV, we also have a globe just sitting around. So if the kids have a question about the globe, or some part of the world that they've heard about, they can easily explore that on this globe, and they have a good time with that. So they're learning geography at their own pace in a way that's fun for them. And they know that, that's where we are on the globe, and they can look around and see where other things are. And this in coordination with the Geochron, which I also keep turned on in the same room. So it's a room where they would normally watch videos or any shows. If it's time to watch a show, we use that TV. And when we're not watching a show, I turn on the Geochron as sort of the default screen on that TV. So it's kind of fun. They're able to see and understand what the Geochron is showing. And then they understand from a combination of the globe and the Geochron. They learn some stuff about geography and the change of seasons and where it might be daylight or nighttime at any given time in the world. So the other day they asked a really good question. They said, where is the place on the earth that is the farthest away from where we are right now? Okay, opposite end of the earth. And I thought, well, I could get out the globe and I could try to, position my fingers at opposite ends and say, well, it's over there. But then I thought, well, maybe I could be a little bit more precise about it. So I happened to have my phone in my pocket, and I just went on there and I looked up, farthest place away from, say, Salt Lake City, because we're pretty close to Salt Lake City. And that's when I discovered a term that I really hadn't heard before, antipode. Antipode officially refers to the place on Earth that is farthest away from where you are on the Earth. So if you're on the surface of the Earth over here, the farthest you could go in any direction would lead you right over to this antipode. Or if you could make a straight line from where you are down into the exact center of the Earth and have that line come out the other end, then that's where your antipode would be. So also I was able to look up, what's the latitude and longitude of Salt Lake City, and then what is the antipode? And it showed me, and I kind of looked for that on the globe or on the map, and I saw that, well, it's over here in the Indian Ocean. So we thought it might be fun if the antipode was an island or, some other country we could go to and visit, or even just imagine that, right? That would be fun. But since it's in the middle of the ocean, it's not as fun to imagine just being, out there on a boat or bobbing around on the surface of the ocean somehow and saying, oh, isn't this fun? We're on the opposite end of our house where we live. So, but the antipode, the whole concept of the antipode, it got me thinking. And I got thinking, well, first of all, I didn't need to look up the antipode. I just needed to know the latitude and longitude of where I was in order to get that antipode. Or, pick some other spot on the surface of the Earth. If I know the latitude and longitude, I can quickly calculate the antipode. So the way that works is, for example, and let's just round off the numbers here for the fun of it. So Salt Lake City is about 41 degrees north of the equator. So the antipode, it would stand to reason, would be 41 degrees south of the equator. Okay, but it has to be on the opposite side of the world from, east and west. So let's just say that Salt Lake City is about 112 degrees west of this prime meridian that runs through England, okay? So 112 degrees west that way. So the opposite of that would not be 112 degrees east, because we have to calculate this based on 360 degrees to get around the entire world, or at least 180 degrees to the west, or 180 degrees to the east of the prime meridian. And once you get past 180 degrees, then you're coming around the other side. So here's how you calculate the your antipode based on the prime meridian. If I'm 112 degrees to the west, then I want to be 180 degrees opposite of that on the other side. So I could take 180 degrees and subtract 112, and I would get 68 degrees. So I come here, the 112, and then go an additional 68 degrees to the east, and then go that 41 degrees south of the equator, and that would take me to the antipode. Pretty easy to figure that out. So whether you're east or west, whatever the number is, let's just say the number is 80. Then you take 180 minus 80, and now you get 100. So instead of being, say, 80 degrees to the east, you'd be 100 degrees to the west, and that would be the antipode. And then again, just calculating north or south of the equator. And so it's pretty easy to figure out your antipode. Now, the only trouble is, like I said, we thought it would be some exotic fun place we could talk about as our antipode, and it's in the middle of the ocean. Since the Earth is 70% covered with water or ocean, most places where people live, if you figure out the antipode, it will be in the ocean. So there are some places that line up, however. For example, the southern end of South America, the antipode for that would end up here in China. So there are some places that correspond that way. And New Zealand, there are parts of New Zealand that correspond with some places up here, in the European British Isles type area. And some places like maybe Hawaii ends up in Africa. But for most of us, your antipode location will be in an ocean. If you are in Australia, basically all of Australia here, the antipode would be in the North Atlantic Ocean, and not a very exotic place to go visit if you wanted to do your corresponding, Australia antipode expedition. Now, as I thought about the antipode and this interesting question that the kids brought up, I thought, if it's the opposite side of the world, then it should be the opposite when it comes to the seasons. Summer here, winter there, right? And also day and night. So every day, sunrise here should correspond to sundown over at the antipode. Sundown here should correspond to sunrise over there. And anytime it's daylight where we are, it should be nighttime at the antipode. Is there any way I could prove that? Well, I guess I could shine a light at this globe and just kind of, turn it around and observe both ends. Or maybe I've got something that would help me graphically represent that a little more easily right here. So I decided to take our antipode and put it as a custom pin on the geochron so we could compare the location of Salt Lake City and its antipode. And with the newest geochron update that allows me to manually set the time and date on this geochron, I can quickly go in there and demonstrate how these 2 points correspond to one another on different days at different times. So let's take a look at what that looks like. So first of all, let me just show you how I do this on this Geochron Atlas device. First of all, I go into the Custom Pins tab here, and I create custom pins. So here's my custom pin for Salt Lake City. And you can see I put in some pretty accurate numbers for latitude and longitude for Salt Lake City. And I created the antipode using the corresponding numbers south of the equator and also on the other side of the prime meridian. So they should match up pretty well on the map. Now I go back to the map, and now you can see that relationship, Salt Lake City up there, and way over on the other side of the map in the ocean, the antipode over there. And you can see that it's daytime in Salt Lake City, nighttime at the antipode. That's great. But what if I show you a little bit closer to, sunrise and sunset, and you can see that comparison. So when I manually set the time to what would be about sunrise for that day, now you can see that it's just about sundown at the antipode, whereas up here, let's find Salt Lake City, it's sunrise. So yeah, that does tend to correspond as I would have expected it to. Now, you could say the atmosphere causes some distortion in the light coming from the sun, so those times that are exactly at sundown or sunrise don't maybe necessarily line up exactly, but it's close enough to prove the point. Now, what if I did, I'm going to change this, Salt Lake City will be sundown now, and let's see how that looks. Okay, there you go, and let's go down and find the antipode, and there it is. Okay, yeah. So again, corresponding sunrise and sundown, you can see graphically for those points. Now let's just, for the fun of it, go to the extreme examples, say the first day of summer. Here's what it looks like about the time of sunrise in Salt Lake City, and sundown over there at the antipode. And there is Salt Lake City's sundown, while the antipode is experiencing sunrise at that time. And then I thought I'd do a couple examples here of some places in South America that would line up pretty closely with some places in Eastern Asia. So there's Santa Cruz, Bolivia, and Buenos Aires, Argentina. And how do they line up with, say, the China area? Well, there's my anti-cruise, and there's my no Buenos Aires, Argentina. So yeah, pretty close to China there. That southern end of South America does kind of line up with the mainland China there a bit. But like I said, most places on land, the antipode would be somewhere in the ocean. And then, of course, the kids are always a little bit fascinated by Denali because they've seen that show. So way down here, bottom of the map, I've created an anti-Denali to show the antipode for Denali. I tried to create one that would correspond to Prudhoe Bay, but it turns out that the geochron by default just doesn't show that far south because there's really no significant population that far south. So when I tried to input what would be the antipode of Prudhoe Bay, that was beyond the range of the geochron to show that. And if you take a look at the geochron closely, you'll see that the equator is not exactly in the middle, from top to bottom of the geochron. It is offset a little bit. But anyway, that's my little geography lesson and timekeeping lesson inspired by my clever children. I thought I'd share that with you and maybe, teach you a word you didn't know before. Antipode. It's kind of fun to think about. Kind of fun to see how it's represented here with the assistance of the geochron. All right, and that's all for this week, but I'll have another episode coming up next week, so I hope you'll come back here again for another edition of the Good Timekeeping Show. Oh, and in the meantime, I better change this back to automatic time display instead of manual display, because my kids will get mad at me if they look at the geochron and it's on the wrong time.